Hello, my name is Zhendong Wang, a PhD student in the software engineering program at the University of California, Irvine. My research focuses on expert developers and how their behaviors exert impact on software projects, particularly in the open source community. Today, I would like to go over my dissertation proposal on assisting the elite-driven open source development through activity data. The open source software is one of the major engines for digital innovation. It has received tremendous attention from both academia and industry for the past 2 decades. Prior literature suggests that there is only a small portion of developers who substantially drive the development of the open source software and its community. Our advanced understanding on this group of developers has broad implications for research and practice. In my dissertation, in order to understand and support the development of the open source community, I particularly focus on the central group of developers. Though the central group of developers in the open source community has been studied in various contexts. For example, research on community structure and hierarchy often applies the notion of core developers. However, in my dissertation, I apply the research construct of elite developers, which is based on developers' privilege and responsibility, as I am particularly interested in their activity enabled by their administrative privilege. The notion of elite developers refers to a small admin group in the community. Their administrative privilege enables them to maintain a diverse portfolio of contributing activities, and their activities substantially drive the success of the OSS community. To empirically investigate developers' activity profile and their impact on the project, I implement an activity analysis framework. It collects activity and project outcome data from 2 data sources, GHArchive and GitHub REST API. It generates the activity profiles for developers. It identifies the trend of effort allocation on various major categories of activities. And finally, it identifies impact of such dynamic effort allocation onto the project technical outcomes. To reflect the developer's effort allocation on various development activities, I create an activity category system, which categorizes over 30 GitHub events under 4 categories, including communicative, public and visible communications through commenting features on issue, commits, and project milestones, etc. Organizational, managing the project community and delegating tasks through teammates, such as assigning code reviews and managing the organization's internal and external developers. Supportive, non-coding activity in the collaborative open source software development, including documentation and versioning control. And finally, typical, conventional coding tasks at the individual level, such as submitting code reviews, commits, and pull requests. For each goal of the activity analysis, I carefully select its statistic analysis methods. For summarizing developers' activity profile, we simply employ the descriptive statistics method. We also employ the descriptive statistics and one-way ANOVA to identify and compare the trend of contributing efforts into various activity categories. To test the relationship between efforts and project outcomes, we employ an advanced econometric method and the fixed effect panel regression, which befits the nature of the collected longitudinal data. By leveraging this analysis framework, I aim to investigate the behavior of this developer group in the GitHub environment. I sample a set of large-scale open source projects and ecosystems based on their management structures, activity records, and project types. The sample enables me to empirically investigate elite developers' activity patterns and outcome status. Through the analysis on the activity profile, I find these elite developers spend substantial efforts into various non-coding activities, especially in later stage of the project development. Our activity trend analysis also suggests that they start the project majorly as code contributors, but gradually move to the management positions in the community. In addition, through comparison across project and ecosystems, I find that there are some project-specific patterns. For example, elite developers in smaller add-on projects usually have to bear heavier workload. Based on the panel regression results, we find that in general, elite developers' efforts on non-typical activities has a negative correlation with the project's technical outcomes, but for both productivity and quality. According to the results of my empirical studies, non-technical activities increase elite developers' workload, but negatively impact the project's technical outcomes. Therefore, with the current advances in the bot techniques, I propose to leverage small-scale automation techniques to assist elite developers with their non-technical activities. Future work starts with the unveil studies with elite developers. I will specifically ask questions about the elite developers' daily workflow and their interaction and the user experience with the bots, so I can further understand elite developers' preferences, usage, and the experience with the current automation assistants in the GitHub environment. Then I may implement the toolset of automation which fulfills the specific needs of developer and the project without interrupting their routine workflow. Further, I can iteratively refine and improve the proposed automation toolset with the user-centric activities such as design critics workshop to modify and refine the design and the requirements, and diary studies to improve the user experience with the bot.